Hello there, welcome to the engineering video lectures. As we know that the engineering mechanics always deals with the rigid bodies, and we are trying to find out what are the forces are acting on that member. At the same time, what are the forces are going to be generating inside the member. That's going to be we are dealing. So as we know that, so when we are going to be using, because different procedures and different concepts we are using to find out the forces in that respective members, and in this case we are going to be trying to see the equations of equilibrium methods by using the free body diagrams, right? So here is the problem is that the two smooth spheres P and Q, so there is there two spheres are there, the P and Q. I'm going to be calling this is going to be the P as well as this is the Q, and the two spheres smooth spheres P and Q, each radius is going to be 25 centimeters. So that's going to be your RP is equal to RQ is equal to 25 centimeters. It means the sphere is going to be have 25 centimeters radius. It means the diameter is going to be considered as the 50 centimeters and weighing 500 newtons. That's going to be your weight of the sphere, the P, and weight of the Q is going to be around 500 newtons each. Rest in horizontal channel having a vertical walls. So these two spheres, they are trying to mount it on the two objects, that means the two spheres mounted in a respective channel. So that's going to be, it has a vertical wall, at the same time it has a floor. So can you see, if the distance between the walls is 90 centimeters, it means the vertical walls, the distance between these two is going to be, I am taking the 90 centimeters. The distance between the walls is going to be the 90 centimeters. Determine the pressure exerted on the wall and the floor at the points of contacts A, B and C. I am going to be taking which is going to be contact. The P have a contact with the vertical wall here, at the same time at the floor, and the Q have a contact at the another vertical wall. So this is going to be your A, and this is going to be the B, and this is your C. Those contact points I have taken A, B and C. See, then we need to find out the reaction forces. That's going to be your RA is equal to how much, RB is equal to how much, RC is equal to how much. So these reaction forces we need to be calculated. So then how we are going to be calculating here? So by using the equations of equilibrium and by considering the object is existed in the equilibrium condition. Once the equilibrium condition is going to be existed, means the summation of the forces acting on that body is equal to 0. It means we are going to be applying the concurrent and the coplanar force system, and then we are going to be applying these equations of equilibrium. So once we had the problem as well as the given data, now we need to find out some of the geometrical properties and which is going to be helpful for the identifying the reaction forces. There we can see, if I am going to draw the free body diagram for the sphere B as well as the Q, so then what will happen? So then in this case what will happen, when I am going to be draw the free body diagram for the P, the free body diagram is nothing but initially we are going to be removing all the supports. That's maybe here is going to be the supporters are going to be, I am removing at A. So this is going to be your A, and the B as well as the Q ball I am going to be removing. So then in this case what will happen? So when I am going to be draw the free body diagram for the P, so then in this case RA, RB and RPQ. So then what happened? In two equation the three unknowns are going to be existed. So then it is going to be very difficult to solve it. So then what I am going to do, I am going to be taking the free body diagram for the Q. There we can see, so when I am going to be removing all the supports, means it is going to be supported by the P as well as the C wall. So if I am going to be removing, so there is going to be a reaction force is going to be coming over here, and another reaction force is from the vertical wall. So then here is the two forces we do have along with the self weight of the Q. So the two equations, the two unknowns, easily we can solve it the problem, right? And after that we are applying for your body P. So now what I am going to do, if I am going to be taking the centers of these balls, can you see, then what is the inclination it is going to be existed? This theta I need to be calculate. If I am going to be calculating the theta theta over here, so that the direction of your reaction force I can calculate easily. If I am not going to be finding the theta, then it is going to be very difficult to follow the direction, which direction it is going to be acting exactly. For this one, I am going to be trying to find out over here. So can you see? So this is going to be your ball Q, right? And similarly, this is going to be your ball P, suppose we do have. And these are going to be the centers of your P as well as the Q. That I am going to say this is the C1, CP, and this is going to be your CQ. So then when I am going to be measuring, the vertical wall distance is going to be the 90 centimeters. So that means from this part to and this contact point is going to be 90 centimeters are available. Right? The 90 centimeters are there. At the same time, we know the distance, that means the radius of the sphere P and the radius of the Q is going to be the 25 centimeters. It means that the diameter is going to be the 50 mm and this diameter also the 50 mm. So then I am going to be measuring the distance from here to here. What is the distance we do have here? So that's going to be 25. So when I am going to be joining the CP as well as the CQ, that is the centers of your spheres. So then I know this is the 25 and this is the 25. So the total distance between the CP and the CQ is going to be 50 mm. So then I need to find out the distance between the projection of this. Can you see? When I am going to be taking the projection of your center, it is going to be intersecting your horizontal point. And I want to find out. So I know the distance between this is going to be your 25 centimeters. Then what is the distance over here? What is the distance we are going to be getting here? So that I am going to be taking the distance, suppose CP, CQ, and I am going to be say this is going to be the point is going to be the D, suppose. So the CP distance is equal to CP D, that is equal to, that is going to be center P, center CP and D. So the total distance is going to be 90 centimeters and this distance is going to be the 25 and this distance is going to be the 25. Can you see? 90 minus 25 minus 25. It means that the 50 we are going to be getting here. 90 minus 50 means I am going to be receiving here is the 40 centimeters. This means the distance between these two is going to be the 40 centimeters. I got it. And already I know the distance between your center of this one is going to be your 50 centimeters. Now I am going to be the triangle of your CP and the CQ and the D, so that I can calculate the angle theta here. Right? If I am going to be calculating the theta here, because I know the 40 centimeters distance between these two and I know the diagonal of the CP. So then in this case what will happen? I am going to be considering here is the cos theta. If I am going to be taking the cos theta, so then what is the equations we are going to be getting? That's going to be adjacent side by hypotenuse. So here is the adjacent side is going to be your CP D if I am going to be taking, that is the adjacent side. By hypotenuse is going to be the central distance CP as well as the CQ. So that I am going to be taking CP CD is equal to how much it is over here? CP CD is going to be 40 divided by CP CQ is going to be the 50. So on that basis I am going to be calculating the theta. Then what is the value of the theta over here? So the theta is equal to here I am going to be getting, that's going to be cos inverse, that's going to be 4 by 5 when I am going to be cancelling the 0. So now after this one, after the simplification of this one, the value of the inclination, that means inclination to the horizontal plane, that I am going to be getting around 36.87 degrees. Can you see? I got the theta value over here. So that theta is equal to, so I am going to be theta is equal to 36.87 degrees I have taken. Once if I am going to be calculating the inclination, that is going to be representing the direction of the reaction force between the P as well as the Q. If once I am going to be taking, then I will take the free body diagram of the Q, then I can calculate the unknown parameters like RC as well as the RPQ forces we are going to be calculating. So now I am going to be draw a free body diagram. Free body diagram for Q sphere. So I am going to be taking the free body diagram over here. That's going to be your Q. Initially the sphere I have taken. The free body diagram is nothing but first we remove all the supports and show with the reaction forces, so that we can keep the body is in the equilibrium condition. It means we are not disturbing any equilibrium condition of your Q from the set position, right? So then in this case, when I remove the vertical wall, so then what happened? The ball is going to be trying to fall that side, but I want to keep that object is in the same position. So first I am going to be taking the center, and the self weight is going to be always acting vertically downward. As you know, the self weight is going to be here is going to be 500 newtons. At the same time, the reaction force is going to be coming from over here. That's going to be towards this side. So that's going to be your RC force is coming from your vertical wall. And similarly, when I am going to be removing another support, that is the sphere P, so then there is going to be another reaction force is going to be coming over here. This is going to be your R, P, Q I am going to take, because the reaction force is coming from the P to the Q. And we know that the inclination of this one, it is going to be making around the theta inclination. That's going to be 36.87 degrees we have derived. So from this one, we need to calculate your RC as well as the RPQ. So then what I am going to do for this part? So we need to apply the equations of equilibrium. What is the equations of equilibrium? That's going to be summation of the forces in the horizontal direction is equal to 0. At the same time, the summation of the vertical forces are equal to 0. So then we can calculate easily. So what is the first equation? That is going to be sigma f of x is equal to 0. Can you see how many forces we do have in the horizontal direction? Right? The first one is going to be your RC force, which is acting directly in the horizontal axis. But when it comes to the RPQ, it is making an angle theta. As we know, the theta inclination. I am going to be resolving this RPQ force in terms of your horizontal force, in terms of your vertical force. So this is going to be your RPQ cos theta, RPQ sin theta. So these two forces, and I have resolved this force into the two. I am going to be removing this part, because already one force I am going to be resolving to the two. So sigma f of x is equal to 0, as we know that the positive direction is going to be your towards the right side, and the negative direction towards the left side I have considered here. Alright, so that is going to be your sign conventions. So now I am going to be taking here RC is going to be acting towards this side, RPQ cos theta acting towards the right side. Right, so that is going to be RPQ cos theta minus RC is equal to 0. Now that is the equation of motion, that is equations of equilibrium we have received. So then I need to be find out the RC as well as the RQ, because in single equations two unknowns are going to be not possible. So then what I am going to do, I am going to be taking the second equation, that's going to be sigma f of y is equal to 0. So in this case, how many forces are there in the vertical direction? Yes, there is two forces are there. The first one is going to be RPQ sin theta, which is the resultant component of your RPQ. So that is acting vertically upward direction. And similarly, another force is there, that is the self weight of the sphere, that is acting in the vertically downward direction. That's going to be WQ. So I am going to be taking upward direction is going to be the positive, and the downward direction is going to be the negative. So this sign convention is not the standards. As you wish, you can also alter that part. So I am going to be taking RPQ sin theta minus WQ is equal to 0. Right? I know WQ is equal to 500 newtons. I know theta is equal to 36.87. By using these two parameters, I can calculate the RPQ. So how I am going to be writing? That's RPQ is equal to WQ by sin theta. So that is equal to 500 by sin 36.87. Right? So what is the final value from this part? And we are going to be receiving your RPQ if you are going to be deriving from this part. So I have received, that is going to be RPQ is equal to, that is around 83.3 newtons. I have got it. Right? If I am going to be resolving this equation, finally I got it 83.7. That is going to be, that is your RPQ. So that is going to be your RPQ is equal to 833.3 newtons. This is the derived units I am going to be keeping over there. Now once if I am going to be getting that my RPQ, so that I am going to be substituting in this first equation. Can you see? In this equation is equal to RPQ cos theta minus RC equal to 0. If I am going to be substituting RPQ is equal to in this one, then I can get the RC. Now substitute over here. RPQ is equal to RC is equal to, I am going to be taking towards the right side. So that's RPQ is equal to 833.3 newtons and cos 36.87 degrees. Can you see? So if I am going to be simplifying this equation, RC is equal to, what is the value of the RC? If we are going to be simplifying this equation, RC is equal to, I got it around 666.6 newtons. Can you see? That same thing I am going to be writing here, 666.6 newtons. Right? One reaction force I have calculated. And we need to be calculate your RA as well as the RB. If I am going to take the free body diagram of your Q, so that I can calculate easily. Now I am going to be draw the free body diagram for your P. This is the sphere P. So then same, the sphere I have taken, this is going to be the P. So now the self weight always acting in the downward direction, that is going to be WP. So that is acting. Then where it has a contact, can you see there is a contact with the vertical wall as well as the floor as well as the Q. So these three I am going to be removing and show with the reaction forces, so that I can keep the bodies in the equilibrium condition. So then I can take it. This is going to be the force is coming from your RPQ or QP also we can consider. At the same time, the reaction forces from wall to the ball I am going to be taking. So can you see here? This is going to be your RA. And similarly, there is a force is coming from your floor to the ball. That is going to be showing in the reaction forces, that is going to be your RP. Is it clear? This is the way we are going to be draw the free body diagram. If I am going to be taking the line of actions, these are all going to be meeting at one point. That's why we are going to be say these forces are going to be concurrent and coplanar forces. And I am going to be applying the equations on. As we know, this is going to be the theta, already we do have calculated. Now I am going to be taking the horizontal forces as well as the vertical forces. Can you see how many vertical forces would you have? WP and RP. Right? Can you see RPQ is in the inclined position. So what I want to do? I want to resolve this force into, one is going to be the horizontal, another is in the vertical direction. So when I am going to be resolving the horizontal direction, the force is going to be trying to move towards the left side. So then this is going to be your RPQ cos theta. And similarly, another force is going to be resolving into the vertical direction. So that is going to be your RPQ sin theta. Can you see the single force I have resolved into the two components? The one is going to be vertical, one is going to be the horizontal. Then I am going to be removing this part for my convenience. So can you see? So this force is going to be downward direction. Right? In horizontal direction, suppose I am going to be applying the equations of equilibrium equations. That's going to be sigma f of x is equal to 0. Then how many forces we do have? One force is going to be RA and another is going to be your RPQ cos theta. The same directions, towards the right side is going to be your positive and towards the left side is going to be your negative sign conventions I have taken. Right? So then what I am going to do? I am going to be applying here. That's going to be your RA towards the right side minus RPQ cos theta is equal to 0. This is going to be your equations of equilibrium. So then RA is equal to, RPQ is equal to how much we got it? That is 833.3 newtons and cos 36.87. Can you see? And finally, what is the value of the RA? Right? So I got it around 606 newtons. I got it. The way we got it the RC, and we got the same for the RA from the vertical wall. So that's going to be 666 newtons. So now we have calculated your RA as well as the RC, and rest of the thing is going to be your RB. If I am going to be taking sigma f of x is equal to 0, so that I can calculate your RB also from these equations. So here that's I'm taking sigma f of y is equal to 0. So sigma f of y is equal to 0 means how many forces? Upward direction is going to be your positive and downward direction is going to be the negative I have taken. So there we can see the two forces are acting in the downward direction and one reaction force from the floor is acting in the upward direction. That's going to be your RB minus WP minus RPQ sin theta is equal to 0. So can you see, this is going to be your equations of equilibrium. I know RPQ and I know WP and the theta. So then RB is equal to 500 plus 833.3 sine 36.87. So if I am going to be simplifying this equation, I will going to be receiving your RB. What is the value of the RB? If I am going to be simplifying, that's going to be around 999.98 newtons. That is approximately 1000 newtons are coming from the floor, the B. So that I am going to be taking 1000 newtons. See, this is the way we are going to be solving the equation. Whatever the data he has given, the first we are going to be converting into the pictorial view. Once the pictorial view is going to be clear, then we can draw the free body diagram by removing all the supports. Once you remove the supports, then we need to keep the body in the equilibrium condition. Then we will show with the reaction forces. That is coming from your A, B, C. When there is a attachment is going to be removing between the spheres P and Q, there is another reaction also will going to be developed. That's we need to be shown. By using that equations, we are able to calculate your RA, RB and RC. In this process, some other parameters also we derive. What are those parameters? That's the parameter 1 is going to be your geometrical property of your inclination. That's going to be the direction of your reaction force between the P and Q for the finding we have used. And similarly, that's the magnitude also we do have calculated. Right? If once you are going to be calculating these two, rest of the parameters are going to be very easy to you. I hope you are able to understand the concepts of your engineering mechanics and how to apply your free body diagram as well as the equations of equilibrium. If you feel any difficulty or any confusions and still if it is going to be existed in your minds, please put in the comment section so that I can reach you. Okay, I hope you are able to understand the concepts whatever we have discussed. Thank you.